Hey everybody, this is Simon from Code Standard. We continue solving binary tree related problems. This tutorial will look at how to solve the problem height of a binary tree. We are given a root of a binary tree and we need to return the height of the tree. Let's see an example. The height of the binary tree is the number of edges in the longest path from the root node to a leaf node. This tree has two leaf nodes 5 and 8. The path from 7 to 5 has two edges, so the path equals 2. The path from 7 to 8 has only one edge, so the path equals 1. The longest path is the path from 7 to 5, so the height of this binary tree equals 2. Let's see another example. This tree has only one node, and this node is the root node. The tree does not have any leaf nodes. That's why the height of this tree equals 0. Let's see one more example. This tree has three leaf nodes 5, 1 and 9. The path from 7 to 5 has two edges, so the path equals 2. The path from 7 to 1 has three edges and the path equals 3. The path from 7 to 9 has only one edge. As a result, the path equals 1. The longest path is the path from 7 to 1 and the height of this binary tree equals 3. To calculate the height of the binary tree, we calculate the height for the left subtree, the height of the right subtree, then get the max from these two heights plus 1. To implement this algorithm, we will use the same recursive technique what we used to calculate the size of a binary tree. Let's see the implementation. The implementation is using a recursive approach. And as usual for recursive algorithms, we're starting from the base case. In our base case, we check if the root is null, and if so, we return -1. Otherwise, we calculate the height for the left subtree, then for the right subtree, get the maximum from these two heights plus 1 and return the result to a calling function. Let's see how this code will work on an example. This binary tree has only one node, and as we already know, the height of this binary tree equals 0. We are starting from the root node. The root node is not null. So we call the height function with the left child node of the root. The left child is null, and the function returns -1. The left height equals -1. Now we call the height function with the right child. The right child is null too. So the right height equals -1. We calculated the height of the left subtree and the height of the right subtree. The function returns a maximum between heights of the left subtree and the right subtree plus 1. The maximum between these two heights is -1 and plus 1 will be 0. So the height of the given binary tree is 0. Okay, let's see one more example. As usual, we are starting from the root node. The root node is not null. So we call the height function with the left child node of the root. The left child is 4. Node 4 is the new root node and it is not null. We go to the left again. Now node 5 is the new root and it is not null. We call the height function again and passing the left child of node 5. The left child is null and the function returns -1. Node 5 gets -1 from the left side. We continue the execution and call the height function with the right child of node 5. The function returns -1, so the node 5 gets -1 from the right side as well. Okay, now we are ready to calculate the height for node 5. The height for node 5 equals 0 because the maximum between left height and right height is -1 and plus 1 will be 0. Node 5 returns 0 to its calling function. Node 4 got 0 on the left side. We continue processing node 4 and call the height function for the right child of node 4. The right child is null and the function returns -1. Node 4 gets -1 from the right side. The height for node 4 equals 1 because the maximum between left height and right height is 0 and plus 1 is 1. Node 4 returns 1 to node 7. Okay, we completed processing the left subtree of the root and call the height function for the right child of the root. The right child is 8. Node 8 is the new root and it is not null. We call the height function and passing the left child of node 8. The left child is null, so the function returns -1. Node 8 gets -1 from the left side. We continue the execution and the height function with the right child of node 8. The function returns -1, so the node 8 gets -1 from the right side as well. The node 8 has -1 from both sides. As a result, the height equals 0 and returns 0 to the root node. The left height of the root node is 1 and the right height is 0. The height of the binary tree is the maximum between 1 and 0 plus 1. So the height of the binary tree equals 2. The time complexity from this algorithm is O from n, where n is the number of nodes in a binary tree. I hope this was educational for you. Thank you guys for watching, see you in the next video, and have a nice day.